To understand Spring, let's take a look at the very simple application, and also let's go over how Enterprise has changed over the years in Java ecosystem. So for example, in this case, we have a very simple example. We have a very simple application where we have a notification service which send an email to a user. So we have for the notification service, we have here email service, and we are creating an email service version 1, and we are calling the send method of that email service. And also for the email service, we have the email service version 1, where we have the implementation, which is basically here printing that email and whatever message we are passing. But also we have email service version 2, with the new implementation of it. So what happens that if we want to change the implementation from version 1 to version 2, what happens is we need to go and physically in the notification service, we need to change the implementation from version 1 to version 2. That's okay if you have a small application, but let's say you have hundreds of classes across your application, and what it means is you need to go and for each of the implementation, you need to change that you need to change the class, because now we have a new implementation. That's the first problem with this approach. And another problem is that this service, email service, is almost impossible to test. Let's say we have here logic for connecting to the database, or let's say connecting to another service, or let's say we are sending HTTP request to some external system. So in all of these cases, it will be impossible to mock this class, or we have to have full integration test. The unit testing would be hard to write in this case. So around the same time, so Java community started to use another approach, which is that one of the design patterns, a factory pattern. In the factory pattern, so basically creation of the object, considering that we need to more centralized place for the object creation. Creation of the object will move to the factory. So here, for example, what we do is we are creating, instead of creating the email service directly in the notification service, we are externalize that to the factory service, and in the factory service, we are creating an email service version 2. It's better than the previous approach, but still the problem remains. If let's say we are going to change that later to version 1 or version 3 or some others, we need to go and manually change that in our service factory. Also, the problem with the service factory problem with the factory pattern is usually you end up with a lot of factories. So basically you have the factory of the factories, and those factories, so from let's say that the generic factories, you are calling the service factory, and from the service factory, you are getting the email. So it adds up the complexity to the application. Around the same time, another technology, which is that the Java Enterprise Beans were used for the large enterprise application, but it adds some complexities, as you can see here from the code. So we are creating a remote interface, then we are creating implementation for it, and on the client side, we are adding the following code. So the first disadvantage for it was that it required heavy application servers, and also complex deployment, the descriptors and the XML configuration. And also, as you can see here, we need to create the remote interfaces, and the tight coupling, and the testing was nearly impossible. So regarding the disadvantages of the Enterprise Java Beans, it required application servers such as WebLogic and the WebSphere in order to run EJB containers. Also, for example, for the testing, it was almost impossible to test. You can't really test it without the container, and you need to mock the GNDI, and also integration test required the full server startup. So considering all the difficulties with the factory design pattern and with the EJB and the other approaches, around 2003, and another framework was introduced, which is the Spring. Spring was basically based, as other dependency injection frameworks, it basically based in two main ideas. The first idea is of the inversion of control. Inversion of control basically means that we are basically giving those responsibilities for the object creation, maintaining, and so on to a centralized place, to a container. And also dependency injection which is that after those objects are created, those objects are injected to whatever they are required. So for example, in our scenario, what happens is we are creating a Spring container, and in the Spring container, we are creating two beans. In Spring, they are called also beans. So we are creating a notification service bean, and we are creating email service bean. Spring container is responsible for creation of those objects, for the initialization, for setting the values, and for the whole life cycle, and also for the destruction of these beans. So all these responsibilities are outsourced to the Spring container. So as a result, our previous code, our previous simple application main, if we convert it to this Spring, so what happens is that here, instead of manually creating new objects, we are giving that responsibility to Spring, and we are creating two beans here, two components. We are marking with annotation components. So basically, we are letting Spring know that these two are beans, and the Spring create two beans for us. And whatever it's required, for example, in the first case, right, for the notification service, we are in our main, right? In our main, instead of using new, we are injecting our notification service, and in the notification service, instead of creating a new email service, we are injecting email service.